Hello everybody. Today I want to present my project about fast change materials (PCM), improving the energy performance of the building envelope using fast change material. This is my Benachir from Morocco, Hassan Fers University of Stats, École nationale des sciences appliquées, laboratory. So, we present my plan. First, introduction. 2. Methodology. 3. Results. And conclusion. Energy plus with PCM and building. So, the overall objective of the project is to improve the living condition of the local population. The specific objective is to set up a pilot unit using local building materials with low environmental impact and reduce the CO2 provided with organic fast change materials (PCM). Our research strategy aims to examine the PCM used as thermal energy storage materials for the building sector and also verify the performance of PCM and relative humidity inside building and minimize the transition temperature entering the surface from the PCM. We will start the methodology. The reference room is a typical 69.8 meter 3 define zone dimension. Select the zone you want to modify and the plan and edit the values below. We can integrate the PCM fast change materials and the wall and the ceiling and the roof, the PCM and ceiling. Figure 3 presents the evolution of the internal ambient temperature with PCM for the three scenarios. Temperature PCM1, internal surface from PCM, temperature PCM2 and middle, the temperature PCM3 and extern, and temperature extern Casa for zone climatique Casablanca Noisir. So, Figure 3, 4, 5 compare the ambient temperature for three scenarios of walls of different PCM: the internal, the middle, and the external. The internal ambient temperature with PCM1 is 25.8 degrees Celsius and PCM2 26 degrees Celsius and PCM3 26.6 degrees Celsius, and without PCM the ambient temperature is 28 degrees Celsius and a maximum temperature of 2.3 degrees Celsius. In contrast, wall 1 is the biggest control of internal thermal comfort and humidity, large storage for fast change temperature and energy saving. So, a dynamic thermal simulation was performed with transist type 204 to compare the brick wall with the PCM and without PCM. The simulation was performed for the climate zone of Casablanca Noisir. So, the fast change materials represent a sustainable alternative to minimize energy consumption. For this, a dynamic thermal simulation was carried with transient application. So, the study includes a numerical simulation and climate zone Casa Noisir. The results of the simulation showed that the use of fast change material and brick wall minimizes overheating in the summer period, decreasing the ambient temperature and saving total energy consumption for heating and cooling than wall without PCM all month of the year. We passed the character for the effect of thermal conductivity of PCM performance. Figure 6 present evaluation of the thermal conductivity PCM and sour. So, the result about the evaluation of the thermal conductivity of PCM and summer. So, if the higher conductivity, the lower the internal ambient temperature of the PCM, the more material conduct the heat. Figure 7 presents the evaluation of the density of PCM and summer. The density of the PCM is a parameter that directly affects the storage capacity, since it defines the concentration of heat that can be absorbed by the material when the density is increased. The internal ambient temperature with PCM decreases if the temperature increases. The molecule of the fluid move apart and the density decreases if the temperature decreases. The opposite occurs. PCM we can print the 5.6 kilojoule by hour meter Kelvin for conductivity. Figure 8 presents the evolution of the internal ambient temperature with PCM and with PCM 204 and external temperature Kaza and summer. Figure 8 and table 1 shows the evolution of the internal ambient temperature with PCM and without PCM, and external temperature Kaza and summer. The PCM and confirmation attenuates the maximum temperature peaks of 3 degrees Celsius in comparison to the wall without PCM, corresponding to 11.4% of reduction. Figure 9 presents the monthly evolution of the year temperature without PCM and with PCM. We walk the comparison for wall with PCM and wall no integrate the PCM. The results showed that the PCM not only had effects on the temperature and the heat transfer and the wall, but also had effect on the moisture transfer and the wall. The relative humidity of the wall with PCM were both small compared with external relative humidity and the relative humidity of the wall without PCM. The reduction of the peak relative humidity of the PCM wall is 28.6%, with the external relative humidity at 40% of the wall without PCM. Figure 11 presents the PMVM PPD index simulated during 1 year with PCM and without PCM. In our case, the value of PMV with PCM vary between 1 and the summer period. The negative values express very low temperature and the positive values indicate very high temperature. The thermal comfort zone is between +1. An index of the PMV equal to 0 express an optimal feeling of thermal comfort. Figure 40 and table 2 shows the annual heating and total energy consumption. Shows that the walls with PCM require the energy for heating and cooling compared to a building than the wall without PCM and all months of the year. PCM will reduce energy consumption 25%, whereas without PCM consume 311 kWh for heating and generating, but walls with PCM consume only 240 kWh. A gas has the highest consumption during the cooling period. The energy consumption with PCM and a gas was 33 kWh and without PCM 41 kWh. The results show that the presence of the fast change material and the building envelope achieved energy saving by reducing the winter heating period routine. The annual needs for the heating and cooling are set by the Réglementation thermique marocaine according to the climate zone and climate zone 1 Casablanca Nasser Agadir. These annual needs are set at 25 kWh by square meter by year. For residential building, Réglementation thermique marocaine. The previous result clearly shows that the heating and cooling needs are about 40 kWh by meter cube by year. This needs represents only 46.8% of the needs set by the Réglementation thermique marocaine. En conclusion, the integration of fast change materials PCM into the building envelope results an increase in the thermal energy storage capacity. Heat is absorbed or released when the material changes from solid to a liquid state, or vice versa. It is concluded that composite and incorporating PCM are capable of reducing energy costs, minimize the transition temperature and cooling and heating demands of the building, and minimize the investment cost of the necessary cooling equipment. They can also contribute to reduce the CO2 emission associated with heating and cooling. The application of PCM layer can minimize the temperature and relative humidity of the inner wall surface and the fluctuation of convective heat flow. It is concluded that the efficiency of the PCM can be improved if the building can be properly ventilated. So for that, and the next article we will deal with the integration of solar ventilation to improve thermal comfort and energy performance to achieve a positive building. We pass a question. What can integrate the PCM and building? We can integrate the PCM and another building from the encapsulation or with brick, ceiling and gyps. Question 2. If you can use the PCM or another domain. Yes, you can use the PCM another domain, Génie civil or civil engineering, from the infrastructure and the road. We can use it and the cloud. So see you soon and thanks for attention.